Hi everyone, I'm Prithvish and welcome to t2z. T2z is a set of portable libraries that make it very easy to construct and broadcast transactions that go from transparent inputs to shielded outputs. You can think of transparent outputs or transparent addresses to be like the Bitcoin equivalent of addresses within Zcash. And these work in a very transparent manner. Anybody can track the transactions and the balances that you have within them. But the main benefit of Zcash is the ability to have shielded transactions and shielded outputs and shielded addresses, which are part of the shielded pool within Zcash, the latest of which is Orchid. And T2C exposes this very simple interface defined partially by PCZT, which allows us to propose a transaction and then prove the transaction, verify the transaction, get a SIG hash which you can sign externally, which allows interoperability with external wallets, hardware wallets, even air-gapped computer systems. It allows us to combine all these signatures, finalize and extract a transaction which we can then broadcast. So I'll run through a demo which goes through all of these steps, and then we can dive deeper into the actual code and what it all means. This demo is available at t2z-wasm-demo.deformer.com, and every step of the way you'll see the exact TypeScript code snippets which you can copy and paste and run in that exact form. So the very first step is either generating a random key or importing a private key. I'll generate a random key just to go through how it all works. And I'll copy the private key just in case. Now this is a brand new address. This key is loaded into the browser. It's only available in the browser memory. It's only being used for testing purposes, and it won't ever be used again. So feel free to use the private key if you want to. But now we'll get some testnet funds. And now we can see that we have received the input. Faucet has sent us our Zcash. This is our transaction ID, and we were the very first output. So now we can go back and continue to inputs. Now we'll need the transaction ID because we need the unspent transaction outputs. So I'll just copy this over here, and this was the first output, and the value here is going to be 30 million. Because 0.3 ZC was the exact amount that we received. Now we can move on to the payment step. Now I've just clicked generate test recipient address in the payment step. And this gives me a unified viewing key, which will come in handy later when I want to test and decrypt and make sure that I actually received the transaction, received the Zcash over here. And I'm going to just send 10 million Satoshis here. And the memo is going to be private payment from deformer. And if I add this payment, I can continue to propose, and to receive my change, I will send it back to my transparent address. And this is a good demonstration for showing a mixed transaction which has both shielded and transparent inputs. So if I do create PCZT, I can continue to verify, and we can see that this is the total change amount I'll be receiving. I have dummy Orchid output and I have a real Orchid output. This is how it works because we only have one shielded transaction and the other one is going back to transparent. And now I can verify the PCZT, and all the outputs actually match the original request, which means that this is safe to sign. And we can dive into what is verification later when we go through the docs, but I'll continue to the signing step. And so this was the original input. I can sign this. And this indicates that I have authorized this transaction. So if I move on to prove, this is where we can build the actual Halo proving key. So this takes about 7 seconds or so on my machine. So it just got built, and now I can generate the proof, which takes about 10 seconds or so. And the proof just got generated, which means I can continue to finalize the transaction. If I click on finalize, I'll get a complete serialized transaction hex encoded, which I can then broadcast. I have it. So let's copy this and actually try to broadcast this and see what happens. So there we go. We actually were able to broadcast this transaction, and we received this transaction ID. It's gonna take a while before this transaction ID starts showing up on our Explorer. And shout out to the guys at Cyberscan. This is also a project built at Zypherpunk, and it's really handy to test and decrypt shielded outputs online. While we wait for this to be mined and thus be available on chain, let's quickly go back and copy our unified viewing key. This will help us verify that we actually received the payment at this address. Now that the transaction got confirmed on chain, we can decrypt this with our viewing key and see the outputs. First, we can see the actual transparent output. So this is the same address that we sent it from, which seems about right. But let's try to decrypt this, and let's enter the viewing key. And there we go. Is 0.1 ZC private payment from Defarmer. So we were able to decrypt the shielded transaction from the unified full viewing key available in the logs, and that's a demo of the entire 8 steps that it took for us to send this transaction. So let's now dive a little deeper into what's happening really. The setup phase is pretty clear because we have a private key. We don't really need a private key over here. We just derive it because we'll be using it for signing later. But all that we really need to specify is a public key, UTXO, which is an unspent transaction ID, and then the actual index of that unspent transaction, the value that we received. So inputs, what we specify over here was actually this step. The payment step is just constructing a list of payments with their amount, a label, and whether they're shielded or not. And this allows us to specify who do we want to pay this to. Propose is where we do a bunch of the heavy lifting. So when we actually hit propose, we fill the transaction, calculate the fees, and send it back. And within verify, this is where we want to ensure that the transaction is valid before we sign it. So we can verify and make sure that what we proposed is actually the same transaction that we got back. That's basically what the verification tests. And then we have to sign every single input that we want to spend from. And after the inputs are signed, we can aggregate them as happens over here. So you can see there's this append signature being called after we generate a signature. And after that, we have the proving key, which is instantialized once, and it's done lazily. And then the proof is generated, which is also a bunch of the heavy lifting that happens with the wasm module. And finally, once the transaction is finalized, it's ready to be broadcasted. And we talk about how to broadcast it. There's a bunch of ways, but the easiest way is just to use a CLI tool or to use the Zcash Explorer and broadcast it from there. And let's dive a bit more into the actual documentation and what's available within the package. So we ran through the TypeScript example. The TypeScript code is available over here. So you can look at the actual code available, and there's an NPM package available for you to install and use straight away. And we have complete API reference for all of the things that I went through in all the different languages, including Kotlin. And for these other languages, we also have SDKs, which you can explore and figure out how to make it work. We have examples which go through some of the things that we just ran through in the wasm example, and that should help you figure out what to do from there. If you have any other issues, please make sure to file issues, and I hope that this library makes your life much easier in developing Zcash applications. Thank you.